Welcome to the DIY Honda Garage channel. In this presentation, we will be focusing on Diagnostic Trouble Code, DTC P0533, which indicates a high voltage issue in the AC pressure sensor circuit for the Honda CRV model years 2011 to 2016. The AC pressure sensor plays a crucial role in monitoring the refrigerant pressure within the air conditioning system, which is essential for maintaining optimal cabin temperatures and overall system efficiency. If the DTC is triggered, it suggests that the voltage level from the AC pressure sensor is reading higher than expected, typically over 4.75 volts. It's important to follow a detailed diagnostic process to pinpoint the exact cause of this issue, as it can impact the vehicle's air conditioning performance. We'll take you through each step necessary to diagnose and fix the problem effectively. DTC P0533 indicates a high voltage condition from the AC pressure sensor circuit. The AC pressure sensor is integral to your Honda CRV's air conditioning system, as it measures the pressure of the refrigerant within the system. Typically located near the AC compressor, this sensor communicates pressure levels to the Powertrain Control Module, PCM, aiding in system regulation. When the PCM detects that the voltage from this sensor exceeds 4.75 volts, it triggers DTC P0533. This problem could arise due to sensor malfunctions, wiring issues, or faults within the PCM itself, making it imperative to understand the sensor's operation and connection. Precise measurements and checks will provide insight into potential failures and whether they stem from the sensor, wiring, or the PCM. When diagnosing DTC P0533, several possible causes must be considered. First is a malfunction in the AC pressure sensor itself. If the sensor has failed internally, it could output incorrect voltage readings. Next, wiring or connector issues could create an open circuit or short, causing high voltage signals. Inspecting the wiring for corrosion, fraying, or connection problems is essential. Lastly, hardware issues within the PCM may incorrectly interpret the sensor's data, leading to false DTCs. It's vital to systematically check each potential cause to ensure an accurate diagnosis and effective repair. Keeping the vehicle's computer systems updated can also prevent random electrical errors that may occur due to outdated software. Symptoms for DTC P0533 can manifest in various ways, particularly impacting the vehicle's air conditioning performance. Drivers may experience inadequate cooling, which can result in an uncomfortable cabin environment. There may also be inconsistencies in the cabin temperature, where hot and cold air alternates even when the AC is set to a specific temperature. The climate control system may display errors or fail to respond as intended, leading to further frustration. In such cases, it's essential to take notice of warning signs, as they can directly correlate with the DTC and sensory data discrepancies. Understanding these symptoms allows for a more efficient troubleshooting process to bring back optimal AC functionality. The first step in troubleshooting DTC P0533 is crucial to establishing the current state of the vehicle's AC system. Start by running the engine and allowing it to idle. Next, the blower switch must be turned on to enable the AC system. With the Honda Diagnostic System, HDS, at your disposal, check the parameters of the AC pressure sensor. Specifically, look for the voltage reading from the sensor. If the reading exceeds 4.75 volts, this indicates a confirmed fault in the system, and we can conclude the failure is duplicated. If the readings are normal, however, it suggests an intermittent issue and necessitates further inspection of connections and terminals. Systematic approach is essential to diagnose such faults accurately. The The second step in this diagnostic process involves isolating the AC pressure sensor to evaluate its functionality. Begin by turning the ignition switch to the lock position. Once locked, disconnect the AC pressure sensor 3P connector to eliminate any possible influence from external readings. Use a jumper wire to connect terminals A and B within the AC pressure sensor 3P connector, where terminal A is the gray wire and terminal B is the blue wire. This connection bypasses the sensor, allowing you to simulate a direct voltage condition. Next, turn the ignition switch to the on position and utilize the HDS again to evaluate the new voltage output. If the reading returns to a value above 4.75 volts, it confirms an issue with the AC pressure sensor. If it remains normal, focus shifts to potential wiring problems. In the third step, we aim to check the voltage levels directly via the connectors to ascertain the integrity of the circuit. Begin by ensuring the ignition switch is in the lock position. Then, remove the previously placed jumper wire. Now, turn the ignition switch back to the on position. At this point, it is crucial to measure the voltage between the specified test points at the AC pressure sensor 3P connector. This involves evaluating both test points, where a proper reading of around 5.0 volts indicates that the circuit is functioning as expected. If the expected voltage is detected, you can proceed to the next step in troubleshooting. However, if there is a discrepancy, it signifies a potential issue in either the PD sensor line or SG6 line, which requires additional investigation. Step 4 focuses on conducting a continuity check within the PD sensor line. Again, start by ensuring the ignition switch is set to lock, after which you will initiate a short on the SCS line using the HDS. This step allows you to bypass the sensor briefly. Disconnect the PCM connector A, specifically the 49P connector, to facilitate a continuity check. It is essential to measure continuity between the specified test points on the PD sensor line. Under the right conditions, continuity signifies there are no breaks in the wiring and confirms its integrity. If continuity is established, we conclude that the wire is in good condition, and the next step would be to update the PCM or replace it if required. However, if continuity is absent, this indicates an open circuit which must be repaired before proceeding. Continuing with our systematic approach, Step 5 involves checking the SG6 line for continuity. Like previous steps, start by ensuring the ignition switch is in the lock position and repeat the SCS short procedure. Then, disconnect the PCM connector A, the 49P connector, to allow for an uninterrupted continuity test. Here you will be examining the SG6 line by measuring continuity at the defined test points. Confirming continuity in this line also indicates that the wiring is intact and functioning properly. If the connection proves successful, the focus will again shift towards potential PCM issues or software updates. Conversely, should the test indicate a lack of continuity, repairs will be required on the SG6 wire, ensuring connections at both ends are secure. The final repair verification step is critical in confirming that the troubleshooting and repairs have been correctly implemented. First, turn the ignition switch to the lock position and reconnect all previously disconnected connectors to restore the system's integrity. Next, utilize the HDS to reset the PCM, which clears out any previous DTCs stored in its memory. It is also important to perform the PCM idle learn procedure to help ensure accurate functioning of the AC system. After resetting the system, restart the engine and let it idle for a moment. Finally, check again for any pending or confirmed DTCs using the HDS. If DTC P0533 reappears, further investigation may be necessary. Otherwise, the troubleshooting process will be considered complete. Preventive maintenance is vital to ensure the longevity of the AC pressure sensor system and to reduce the likelihood of encountering DTC P0533 in the future. Regular inspections of wiring and connectors can reveal any initial signs of wear, corrosion, or loose connections that could lead to voltage problems later on. Furthermore, ensuring the PCM is updated with the latest software versions will help avoid electrical glitches caused by outdated programming. Additionally, routine checks on the overall AC system, including refrigerant levels and operational efficiency, can help maintain system balance and prevent sensor-related issues. Establishing a maintenance schedule can go a long way in keeping the AC system functioning optimally and prevent trouble codes. In conclusion, diagnosing and resolving DTC P0533 requires a comprehensive and methodical approach throughout each step of the process. Understanding the intricacies of the AC pressure sensor's functionality is essential for effective troubleshooting. The importance of maintaining sensor integrity and addressing wiring issues cannot be overstated, as both are key to ensuring optimal AC performance. Comprehensive testing and verification steps provide clarity on fault isolation and repair requirements, confirming whether the root cause lies within the sensor, wiring, or PCM. Furthermore, adhering to preventive maintenance recommendations will fortify the system against future faults and ensure continual AC efficiency. Staying proactive in identifying potential issues ensures the vehicle remains compliant with performance standards for many years to come. Please like and subscribe to the channel. See you next time.